Hi, I'm Swarupa Sail, course instructor for Geotechnical Engineering 1. In this presentation, we will go through seepage analysis. Two-dimensional flow problems may be classified into two types. One is confined flow, that means flow of water through confined soil stratum, and second one is unconfined flow, that means flow of water through body of the earth dam. These problems are to be addressed in geotechnical engineering in order to meet the objectives like to find out the quantity of flow, that is seepage, in case of both confined and unconfined flow. Second one is to obtain seepage pressure distribution and uplift pressures, that is stability analysis. And third one is to verify piping tendencies leading to instability. Total head causing the flow is equal to H, which is equal to datum head plus pressure head plus velocity head. This is the Bernoulli's equation, which we have already learnt in fluid mechanics. So, H is equal to Z plus P by W plus V square by 2G. In case of flow through soil medium, the velocity of flow is very small. So, velocity head is equal to 0. The flow of water is governed by continuity equation, and the continuity equation for steady state two-dimensional flow with x and y velocity components u and v respectively is given by dou u by dou x plus dou v by dou y is equal to 0. Let this be equation number 1. According to Darcy's law, discharge velocity of flow in a porous soil medium is proportional to hydraulic gradient, that is v is directly proportional to I. If kx and ky are the coefficients of permeability of soil and ix and iy are the hydraulic gradients in x and y directions respectively, and if hxy is the hydraulic head of flow, then u is equal to kx ix, which is equal to kx into dou h by dou x, and v is equal to ky into iy, which is equal to ky into dou h divided by dou y. Laplace equation governs the flow of an incompressible fluid through an incompressible homogeneous soil medium. Combining continuity equation and Darcy's equation, we get dou u by dou x plus dou v by dou y equal to 0, where u is equal to kx into ix is dou h by dou x. Similarly, v is equal to ky into iy, where iy is dou h divided by dou y. We will substitute the equation for u and v in the continuity equation. So, we get dou of kx into dou h by dou x, which is the equation for u, whole divided by dou x plus dou v, where v is ky into dou h by dou y, whole divided by dou y is equal to 0. So, we get kx into dou square h divided by dou x square plus ky into dou square h divided by dou y square equal to 0. Let this be equation number 3. For the case of isotropic soil, the permeability coefficient is independent of direction, that is kx equal to ky equal to k itself. So, equation 3 becomes dou square h divided by dou x square plus dou square h divided by dou y square equal to 0. Let this be Laplace equation. The two-dimensional flow of water through soil is governed by Laplace's equation, and this equation describes the energy loss associated with the flow through a medium. Laplace's equation is used to solve many kinds of flow problems, including those involving flow of heat, electricity, and seepage. Assumptions associated with Laplace's equation are: the limitations are implied by each of these assumptions is stated within the brackets. First one is Darcy's law is valid, that means the flow is laminar. The soil is completely saturated, the degree of saturation is 100%. The flow is homogeneous, that is coefficient of permeability is constant everywhere in the soil medium. The soil is isotropic, that means coefficient of permeability is same in all directions. During flow, the volume of soil and water remains constant, there is no expansion or contraction. The soil and water are incompressible, there is no volume change occurs. Laplace equation is a partial differential equation. So, when Laplace equation is solved graphically, the equation gives flow net consisting two sets of curves intersecting at right angles known as flow lines or streamlines, and equipotential lines. This is the reference. Thank you.